This training video will be about PHP microservices. What we're going to do in this video is learn what a microservice is, learn the pitfalls of microservices, compare the speed of a microservice versus a full MVC, and implement a microservice on our own. Before we get started, you need to take a moment to make sure you've got the required software. You'll need Docker Community Edition, Docker Compose, and Git. You can find links to these resources in the README file of this project. What is a microservice? From Wikipedia, there is no industry consensus yet regarding the properties of a microservice, and an official definition is missing as well. Some of the defining characteristics that are frequently cited include: services can be implemented using different programming languages, database, hardware, and software environments, depending on what fits best. Services in a microservice architecture are independently deployable. Services are small in size, messaging enabled, bounded by context, autonomously developed, independently deployable, decentralized, and built with release automated processes. Services are organized around capabilities, e.g. user interface, front end, recommendations, logistics, billing, etc. Services all share a common security model. Microservices also have a philosophy. The philosophy of the microservice architecture essentially equates to the Unix philosophy of do one thing and do it well. It is described as follows. The services are small, fine-grained to perform single functionality. The organizational culture must embrace automation of testing and deployment. This eases the burden on management and operations and allows for different development teams to work on independently deployable units of code. The culture and design principles must embrace failures and faults, similar to anti-fragile systems. Each service is elastic, resilient, composable, minimal, and complete. But it's not all rainbows and unicorns. The microservices approach is subject to a number of trade-offs. Services can form information barriers. Inter-service calls over a network have a higher cost in terms of network latency, message processing time, than in-process calls within a monolithic service process. Testing and deployment are more complicated. Moving responsibilities between services is more difficult. It may involve communications between different teams, rewriting the functionality in another language, or fitting it into a different infrastructure. Viewing the size of services as the primary structuring mechanism can lead to too many services when the alternative of internal modularization may lead to a simpler design. Let's take a minute and talk about what we just read. Basically, a microservice sits at the end of some messaging pipe, either HTTP in a RESTful service, or at the end of a message queue, or perhaps even memory queue. It sits and listens for some request, takes parameters on that request, and then performs some business function or logic function and returns a result. Now the keys here are that it sits on the end of a pipe. In other words, it's sitting waiting for something to call it. When it gets called, it performs some action, and then after it's done performing that action, it returns the results. It's supposed to be small. All the microservice functions should be related to each other, and it should do one thing or one small set of things and do it very well. That's the general gist of a microservice. But enough theory. Let's look at how PHP might be used to implement a microservice. PHP's approach to microservices is: a PHP microservice performs as much pre-processing as possible. That is to say, as many constructors as possible should have been called before the request even comes in. PHP microservices are usually asynchronous. Now this is a new concept for PHP programmers. JavaScript programmers have understood asynchronous calls for quite some time, but PHP, it's just now getting started with serious asynchronous programming. The expressive framework 3 or better can be used to build a microservice, but a framework really isn't required when building a microservice. Common transports that are used with a microservice include HTTP, frequently used for a RESTful call, WebSockets, message queues, but they can be anything that supports a messaging protocol. SWOL is the preferred method of building microservices as it supports asynchronous PHP. You do not use a web server like Apache or Nginx. Let's take a quick minute or two to talk about SWOL. SWOL is a PHP extension written in C that adds asynchronous support and low-level Unix primitives to PHP. Some of the things it can do include millisecond task scheduling and provides PHP programmers with access to some C-level primitives. Some of the things you can do with SWOL include mapping a file into memory, using a memory pool, and malloking memory directly off the heap. It has direct support for Unix sockets, including UDP and TCP/IP. It has direct support for SSL, TSL. You can use it to shell out to other scripts like Python using exec, and it supports HTTP too. A few more details about SWOL. SWOL should never be used when running under Apache or another web server. SWOL can actually fork child processes, and this frequently confuses Apache and Nginx. SWOL will kill any process that uses too much memory. PHP is known for its memory leaks. The SWOL approach to resolving this problem is to simply kill any process that uses too much memory and restart it. You must restart the SWOL service process for changes to take effect. SWOL loads as much as possible into memory at runtime, so if you don't stop and restart the process, your changes won't get loaded into memory. We'll have more on this later. Many PHP frameworks are now embracing SWOL for building microservices. Zend Expressive microservices are being built mostly around SWOL. These are some of the more interesting details of SWOL, and I look forward to seeing what people build with SWOL as it's a really powerful PHP extension. You can find some cool SWOL examples at the following URLs. You can find links to these URLs in the README of this project. Now that we've got the basics down, let's get started with some example code. As stated before, you want to make sure that you've got Docker and Docker Compose and Git installed on your workstation. You'll also want to disable any existing web server services running on ports 443, 80, 8080, 8081, and 8082. If you have a local copy of MySQL or MariaDB running, you'll probably also want to disable it on port 3306. You can, if needed, make some changes to the Docker Compose YAML file included in the project if you'd like to move its ports around instead. You'll also, of course, need access to the internet. If you haven't already, you'll need to clone the repository from GitHub. Links can be found in this project, but of course, if you have this project, you already have cloned it. You'll also need to clone the submodules, which involves going into the subdirectory, doing a git submodule init, and a git submodule update. Or if you're familiar with a graphical user tool like SourceTree, you can use it. If you haven't pulled the Git repository already, we can start by going to github.com/JSTORMES. Click on Repositories, do a search for Microservices, and we'll copy the link. Next, from a command prompt, we'll git clone And we'll copy that link that we got from GitHub. Next, we'll go into the microservices directory. We'll do a get submodule init and a get submodule update. And this will update our get submodules. Next, I'll open the project in my IDE. After opening the project in your IDE, take a quick look and open the README file. If you scroll down near the bottom, you'll see a section labeled Stuff to Cut and Paste. These are things that we can use to cut and paste into the command prompt or into the code to help speed along this tutorial. Next, we'd like to start our Docker container so we can run some examples. I'm going to start by copying the command to start the Docker container out of the README file and pasting it into our command prompt. You should see the startup of the Docker container, and you should be at a bash command prompt inside the Docker container. Next, we'll go ahead and go into our speed test directory, and we will do a composer install. This will pull down all the composer packages needed by the speed test demo. Finally, we will want to start the PHP web server for the microservices version of the code. And now we can start our demo. You can see the demo by opening the following URL, which you can find in the README. To run the demo, simply click Run Test. We can see that the classic Apache setup took 2,576 milliseconds to run the demo code. The SWOL took 253. Now, running each test again will usually get slightly faster results, with the SWOL Expressive demo now taking only 48 milliseconds to run the exact same code. If you're curious what the code is, you can take a look in the source, app, handler, UUID generator. You'll see that this is our demo code. All we're doing is returning a JSON response with a UUID payload. You can see the actual URLs getting called if you go to your browser and open the UUID route. The regular Apache setup is running on the stock port of 80, and the Expressive setup is running on the port of 8080. You can play around with this code to find out and determine what code is doing what and to test the speed differences. I'd like to take a minute to talk about why we're seeing such speed differences. Let's start by rerunning our test. In the classic Apache demo, the code is calling the Apache server. The Apache server is starting PHP. PHP is loading its config, loading its route, finding its route, then executing the controller. In the SWOL example, the code has already been loaded into memory. There is no Apache server, and it is waiting at the routing logic to get ready to fire whatever controller is needed to perform the function. We see this massive change in speed because SWOL has actually loaded everything into memory and everything has been pre-processed as much as possible before the actual controller gets called. If you think about it, it's like spring-loaded. It's waiting for something to happen. And that goes with the Microservices philosophy. You want to put as much in memory ready to go before the actual call comes in. Continuing the same line of logic, you could open your database connections to other needed services like your Reddit or your message queues, and this will greatly speed up the response time of all of your calls, thus giving you better performance and better speed. Now the trade-off is that your server will be consuming more memory when it's sitting idle. Also, because each waiting service is consuming more memory, you need to keep your services small, thus the microservice name. If you tried to load up an entire large application into memory, it would probably just simply run your server out of memory. And remember that swirl will kill any process that consumes too much memory. Let's see how hard it is to create our own microservice process using Zend Expressive from scratch. So we'll start by getting into the root of our web server. You'll want to go up a level in your directory, and you should be in the directory var www. You can check that by typing pwd. Next, you'll want to run the composer command to pull a fresh project. From the Zend Expressive skeleton, you can find a copy of that command in the README file, and I'm going to call mine my project. For all of the questions, just simply answer to the defaults. After Composer has created your Zend Expressive app, you'll want to go into that directory and add in the SWOL Composer package. Again, you can find the quick command to do this in the README file. And next, we'll want to copy a SWOL config file. I'm going to choose to go ahead and drop back into my IDE and copy it using my IDE. Looking in the speed test directory, in the config directory, under autoload, there's a file called swoolglobal.php. I'm going to take that, copy it, and put it into my project, config, autoload, and next I'll edit it and change the port to 8081 so I know it's a different port than our speed test demo. And finally, I want to start our SWOL server. Again, you can find a quick and easy way to do that in the README file. And I want to test that our code was installed correctly. or by opening it in the browser on that port. Now, something to be aware of here is that there are actually two instances of web servers running. One is running on port 80, and that's the standard Apache setup. And a second one is running on port 8081, and that is the SWOL setup. One thing to be aware of is to be able to run both at the same time in the expressive code, you have to be in development mode. If you're not in development mode, you can only run the SWOL version of the code. Another thing to be aware of is that SWOL and Xdebug cannot be used at the same time on the same instance. The reason is that SWOL's a C library that does multi-threading, and the Xdebug code simply doesn't understand the multi-threading of the SWOL library. Go ahead and take a minute. You can refresh these. Let's pull up our developer tools, and if we do a refresh and look at our network or our performance, we can see how long a particular call to a particular server takes. Go ahead and try it on the different ports and make note of the different speeds. Now we're ready to add some of our own code to the existing project we just created. Let's start by copying an existing controller and renaming it for our own purposes. I'm going to take a copy of the homepage controller and call it a UUID controller. You'll need to copy both the handler and the handler factory. Next, you'll want to go into the code itself and rename the actual name to UUID. And I'll go ahead and strip out anything that I don't think I'll need. And rather than a JSON response or HTML response, I'm going to return a JSON response. Which means I'll need to JSON encode something. We'll make a quick array, my stuff, and we'll give it a value of hello. Next, we'll need to go in and make sure that our factory can return an instance of our new controller. And finally, we'll want to add our route by going into Config, Routes. I'm going to take and copy the existing homepage route, and we'll call our new route API UUID, and we'll want to return a copy of the UUID page handler, and we will call this one UUID. We'll call this route UUID. Note the route name is the last parameter, and it needs to be unique for every route. And finally, we'll need to add to our config provider so it knows how to find that particular class. Again, copying and pasting, changing the name. And we'll see if it works. Now let's see if it works. We can see on the Apache copy it works. But if we don't restart the SWOL server, remember that SWOL loaded everything into memory when we started the server, and we still have a server running in the background. So I'm going to go over and Control-C in the command prompt and restart the SWOL server so I can see what's happening on the SWOL server port of 8081. And again, we see our new code poorly formatted. You can go ahead and take a few minutes, make sure you get the code working. If you run into trouble, you can look at the speed test example. Go ahead, create some examples, change it up. Be sure, though, that you restart the SWOL server to see the new version of your SWOL code. This is something you should play with, take a little time, understand all the implications. But remember that SWOL loads everything into memory, and that's one of the advantages of running as a microservice as opposed to running through Apache. Now let's review some of the new logic we wrote. So what happens when you don't restart the SWOL PHP server? That's a good question to think about. How do we change the route to the controller? Remember, that's in the route PHP file under the config. What's loaded before the PHP server starts accepting requests? In other words, how do you get Expressive to preload your code, and how do you decide what's preloaded and what should be loaded at request time? In other words, preload versus request load. And why would you want to? Development mode. Why did we do this? So remember that if Expressive is not in development mode, it does not support the classic Apache call structure. In other words, you can't run under Apache. Now, that's not a bad thing, especially if you're not using Xdebug. But by enabling development mode and using the Apache path, you can use Xdebug to help you debug certain things. When we open the same site in Apache versus the same site in SWOL, what's the speed difference? What's loaded before Apache starts accepting requests? This is something to think about. And we can open Chrome's developer tools. What's the difference in the speed? More review. What impact would lazy loading have on a PHP microservice? The philosophy of a microservice is that you should preload as much as possible. Lazy loading defers loading as much as possible. So these two philosophies are at odds. Why would you want to open your connections to the database, Redis, etc. before you start accepting requests? It speeds things up. Why are we using Zend Expressive rather than direct PHP? You can write microservices directly in PHP without a framework. But one of the advantages Zend Expressive does is let you use composer packages that were written, say, for Zend Framework 2 or 3 much more easier, saving you a lot of coding time if you already have a large library of composer packages. Next question. Could you do a full MVC in a PHP microservice? And if you did, would that violate the microservice philosophy? My concept is that not necessarily. It would just depend on how much of a problem domain you put into that single service. Even more review. Microservices must embrace faults and failures. What does this mean? So if a single microservice completely fails, should your entire application fail? The answer would be no. Only that small little section of the application would be malfunctioning. If a write-only microservice cannot reach a database, how should it respond? So it should queue up the writes until the database becomes available, and it should notify the operators that it's having a problem. In other words, it shouldn't stop the code from running if it can queue it up and perform the function later. Should microservices be connected to other microservices? In other words, can I call a microservice from a microservice? The answer is yes, and actually that's an enterprise design pattern. with microservices, because everything gets faster, you can call, say, 10 microservices in the time it would take a regular Apache-hosted application to call one. Should a microservice be a WebSocket or TCP socket or UDP socket? The answer is yes. In fact, it can be all of the above and even more. Any transport available. Should a microservice be connected to enterprise queues like TIBCO? Of course. In fact, that is one of the reasons microservices exist. They are an enterprise design pattern specifically designed to allow the distribution of the architecture. Can PHP microservices call Java services? Of course. Should PHP microservices listen for Java services or Java calls over an enterprise queue? Of course. Final thoughts. Microservices lend themselves to an enterprise architecture, not to an application architecture. Microservices are more of a philosophy than a coding standard. Why should microservices all share a common security model? Remember that microservices can call microservices can call microservices. How would the lowest level microservice know the security context of the call that's being requested if they don't share a common security model? In other words, each microservice should pass its security context on to the next microservice that should be able to validate that security context on its own without any other resources. How would this tie into the enterprise architecture? An enterprise is really a collection of common users or common tasks. All of those tasks should share a common security model so that every product inside the company knows what user is calling it and when. If you'd like to, at the bottom of the README file, this link will take you to a quiz to see how well you understood the material. I want to thank you for taking the time to go through this video with me. Microservices are a very powerful structure, and I hope you've had some success and will enjoy the next in our series on using PHP microservices in an enterprise. Thank you.